All right, good afternoon. My name is Scott Gillies. I am the Director of Education and the Georgia Campus Library. I'm joined by Jackie Werner. Jackie is the Scholarly Communications and Research Librarian and based in Philadelphia. We are going to talk about research data management and sharing and open access today. And we only have a couple of guests at the moment, but I wanted to ask you, have either of you deposited research data in a repository before? No? So this is kind of new to you then? All right. So what is data research management? This is the National Library of Medicine's definition of it. And what does it mean to you? By knowing how to store and manage your data, you can take advantage of opportunities like making your research more well-known and helping advance science. You can meet new data sharing requirements. We're going to talk about that a little bit in a minute. And you can avoid problems in the future by having your data available and well documented. Managing your data opens up opportunities. Data in and of itself is useful and can contribute to the advancement of science. You can get credit when your data is used by others in their research, and it's easier to reuse your own data in the future when you have good record keeping and storage. There are data sharing requirements if your research is funded by the government. Starting next year, an increasing number of funding bodies are going to require data management and sharing plans. Also, an increasing number of journals are requiring depositing data in repositories when the article is published. If you follow these links, you can find a great deal more information about this. Previous NIH requirements were issued in 2003, and we have a new set of requirements that went into effect in January last year, 2023. The new plans require a lot more detail about the data that is to be shared, and many more grant-funded projects are affected than were by the 2003 agreements. And you must have a data management and sharing plan. Again, follow these links. The full text of the new requirements are at this link, and then the link on the bottom goes to a template that you can use to help you create a data management and sharing plan. Under the 2003 requirements, only research funded at $500,000 or more needed to be shared. But under the new requirements, data resulting from research funded at any level by the federal government needs to be shared. You must have a data management plan and submit it. And the new requirements require data to be shared much sooner than 2003 requirements. When does it need to be shared? Well, if the research is being published, then it needs to be shared by the time the publication comes out. If the research is not being published, then the data needs to be shared by the end of the research project. What needs to be shared? This is a brief explanation of what needs to be shared and what doesn't. If you follow the link at the bottom, there is a lot of detailed information about what needs to be shared. There's also a new mandate that was attached to the new regulations, known as the Nelson Memorandum. It was published by the Office of Science and Technology Policy. It removes paywalls and embargoes from federally funded research. But what it means is that in addition to the data resulting from federally funded research needing to be shared, the articles themselves need to be shared. This changes quite a number of things. There's a timeline. By the end of this year, federal agencies are supposed to have their new policies in place, and by the end of 2025, everything should be fully implemented, and according to Plan A, all articles will be available free of embargo. This is going to cause a lot of changes in the publishing industry. We will have to wait and see. Why else is data sharing important? It facilitates the reuse of data for other studies and for transparency so that scholars can check the data underlying a study, checking for honesty and accuracy. Data management can help you avoid a disaster. Improper documentation or having one person who understands it or knows where the data is can leave you unable to use it. Losing track of protected health information can cause problems, and keeping data for too long can violate data disposal policies. So what can you do? Understand the data lifecycle, follow best practices, and develop a data management and sharing plan. And Jackie is going to tell you about these things right now.
All right, and let's see if I could properly take over presenting. All right. I believe this is it. Okay. So I'm going to start by going over the data lifecycle. And there are several different interpretations of the data lifecycle. But this one is a good one that we've used from rdmkit.elixireurope.org. And I'll be going over each of these steps in turn. Okay, so for starting with the first step of the cycle. And the most important thing of this is that, first of all, as you might have noticed, it is a cycle. Each step leads to the next one, and then it's going to all start over again. But the thing about planning being the first step is that you're going to be considering all of these steps throughout the process of doing a study. When you are first planning your study, you want to be thinking about what you're going to do with your data at the beginning of it. Privacy protections must be put in place before you start collecting the data. And you're going to have to, if you're going to want to reuse the data, and as Scott just went over, all data is expected to be reusable. And legacy data can be an issue. Legacy data may include identifying information that was difficult or impossible to scrub, especially if it was not conceived of as being reusable data. So when you are making your data, you could make things easier for anyone coming after you or your own lab for your next study, just thinking about these things from the beginning. All right. So for planning, you want to have backup for all data, not just the digital data. And the digital data might be the only stuff that's required to be shared. But things like your paper lab notebooks and paper surveys, they can get lost if they're only in one location and you are not backing them up at all. So even if it's just like we're going to scan the lab notebooks once in a while, make sure to have that as part of your plan. Next, you want to assign responsibilities. This means you have to decide which person or which position is going to be in charge of data collection and in charge of data management. If the position is going to be changing in the middle of your study, if that person is going to be leaving, or even if you think they're going to stay there, but then it turns out they quit halfway through, you have to decide how you're going to pass on responsibilities. This also helps if, say, somebody gets COVID and is out for a few weeks. Next, you want to determine potential repositories or journals. And this I recommend doing here in the process and not after you've done the study, because will these journals require data publication? Will they allow data publication? And what are their guidelines? If you know these guidelines before you start doing everything, it's a lot easier to follow them from the beginning. And I also recommend having journals in mind, like at this point as well, even not for even outside of just data guidelines, because you can know exactly what you're aiming for when you're collecting the data and when you're writing. And you want to determine the budget for the data. Data costs can be part of a grant if you're getting one. This can include if you're depositing in a paid repository, which I'll go over later, or if you have salaries for a data person. Just if you think of it at the beginning, you can include it as part of a grant. Actually, let me go back and make sure that I didn't miss anything. And nope, I'll be going over the rest of this later on in the cycle. Next on, we're going to collecting data. So, important thing to start with is define and list the types of data you're collecting and what file formats they are. If you have a record of exactly what you're collecting and what format you're using, it makes it so much easier just to work with it and also to share it instead of trying to remember, wait, what in God's name is this is this folder full of untitled JPEGs? Next up, you want to preserve your raw data, as well as you're going to be preserving it separately in multiple steps in the process. Having the raw data, sharing that is sometimes required. And also, if you have an issue, then you could always go back to the raw data and try to figure out like where an analysis went wrong. Next up, you want to choose consistent naming conventions. What does that mean? Every file name wants to include the same information in the same order. I'll go to an example of that next. You never want to use the same name in different folders. If you have 14 different files titled data.xlsx for 14 different projects, then it's fine if they're all in their project folder. But sometimes files can go wandering, and then you really don't want to have to go through 14 different files with the same name and figure out which one belongs there. Next up, you want to use underscores and camel case instead of spaces, just because some operating systems can have issues with spaces, and it's easier just to avoid that in case. And finally, you want to be extensible. So instead of just calling something experiment 1, experiment 2, start with 001 and 002. So when it's sorted in title order, it will be actually a numerical order instead of doing experiment 1, experiment 11, etc. And here is a nice complicated example of a file. And this example is image data from rat experiments. So you could see there's 5 different parts of the file name. The first part is the experiment series name. Second part, experiment number, and you can see it's extensible, 0012. Norm is for normal heart, showing whether it's experimental or control group. Lipitor, the treatment provided, and then the slice number. So if you have all of these in a folder, even if one of them goes wandering, you can just quickly look at the title and see exactly what this is and where it's supposed to be. Next off, we are on to processing and analyzing data. And these two really go together. So the first parts of this are having a README file and a data dictionary. And this is absolutely vital for both sharing your data and keeping track of what you're doing with it. README files are going to be general project files describing the organization of where all the files are in your hierarchy, who's responsible for the data, and what instruments you're using. It basically serves as a kind of a manual to the data itself. Like pretty much everything else in here, that makes it really good for people who are reusing your data, and also a lot easier if you're, say, onboarding someone new, or you've come back after Christmas vacation trying to remember everything that was just habit before you left. You also want to have specific READMEs for basically each folder that you're going to be keeping data in. And that can define more specific things as opposed to the entire project, like parameters, contents, date and time formats, measurements, etc. The data dictionary is similar, but that's just going to explain the terms that are used in files and folders. You want to have a meaningful directory hierarchy. Like, you technically could keep everything in one big folder, but you don't want to. So that's just have, say, a folder for, say you'll have a folder for your lab, a folder for the current experiment you're working on, folder for image files, spreadsheets, etc. And you want to double check your data entry. There's a few different ways to use this. If you're using, say, if you're using something like paper, like transcribing paper records, you can just have people do it twice. You could also just schedule, like, have two people to one person enter the data, one person to go over it and check. Tedious, but very helpful. And if you use REDCap, PCOM's survey software and data management software, then REDCap has some methods that let you automatically get data and get double checking into the process itself. So, like, you could have it, you have to have two people go and check it, and you can mark it off on REDCap, and you can easily see whether it's been done and whether it's been double checked. Next off, use consistent missing value coding when you're entering data. Something like 999 tends to be a good one. Just basically a value that you are not going to see in normal use. And it is really important to document all your analyses. So this documentation will include the steps you take to analyze your data and the complete information on what software you're using so you can replicate it. And you will, so if you document these exact steps, then, as I've said before, it has two benefits. One, somebody else trying to replicate what you're doing has an exact list of steps to follow. Two, if something goes wrong and you suddenly have an absurd p-value and it doesn't look like that should come from your data, you can go through the exact steps one by one and figure out what went wrong in the process and fix it. So, like many of these things, it's going to be a little more work at the beginning of things, but it is so much easier to prepare than to fix things without having any of this documentation in place. Okay, then we have preservation. So this is actually one of the processes that you should be doing all the way throughout. But best practices are to keep 3 copies of your data. The original data, something on site, say on a hard drive, external hard drive or something, and something off-site. Now, if you're working with the PCOM intranet, that covers the off-site data use, and that is going to be backed up. Different storage options have pros and cons. You have many options like personal computers or laptops, network storage, external storage, removable storage, remote storage. But if you're not sure about your options, then you can always talk to ITS and just tell them exactly what you need to have backed up. You want to back it up regularly. Hard to replicate data, make sure you back up daily. Another reason why it's good to have 3 copies and not just use like the intranet copy is that if something goes wrong with the intranet, it can take a lot of digging for them to go in and a lot of time for them to go in and restore your data. It's more secure and also easier to have your own backup alongside that. You want to store your final data using stable file formats, and that I will talk about in a minute. Determine how long you're going to have to store the data. So PCOM has our own data storage policies, and it should probably be, I believe it should be in your IRB application, how long you're going to want to store this data. And you definitely have to talk about data security in your IRB application, especially with protected health information. One important thing is that researchers should know who's accessing what data and when. All right, and then we're on to sharing. So in general, the fair data sharing principles are a good set of principles to go by when figuring out how to share your data. And FAIR stands for findable, accessible, interoperable, and reusable. Findable means that it's easy for both humans and computers to find the data, aka you can find, aka it's sortable, findable by searches, and also by like reading with your eyes. Accessible, it should be clear how data can be accessed. That doesn't mean that everything has to be available to everybody. You may have to have a certain authentication to use it. Like, for instance, you have to be have a PCOM login or something like that. But it should be clear what this is. Interoperable means that it's going to be integrated with other data. And that means you want to use some sort of metadata standard, meaning that everybody's going to be describing their data using the same keywords, using the same metadata. And that means that, say, a search will be able to pull in all of this data at once instead of everything being described slightly differently. And finally, it should be reusable. That means you should have a clear license. And so license is going to be usually going to have be a Creative Commons license, which is a license that allows you to share your data or share any sort of work, but still keep copyright to it, still have rights, but says exactly how people can use it. You could have a license that says you could use this as long as you credit me, and most licenses are going to include that. You could also say things like you could use this, but only if it's non-commercial, or only if you don't modify it. And also, reusable means it should meet community standards, like it shouldn't be throwing protected health information around. All right, and then you want to document all the processing needed to ready data, as I've talked about in the past steps there. That documentation is useful. You want to include that documentation, and you want to save your data in stable formats. So some file formats are different than others. I'm not going to go over all of these, but in general, you want to have file formats that are supported by multiple software platforms and have lossless data compression. So for text, instead of using, say, instead of using a Word file, it is preferable to use PDF, HTML, and for tabular data, you're going to want to save it as .csv instead of an Excel file. There are also different levels of file formats. So stuff like Word and Excel is used widely enough and can be opened, is not just openable by proprietary software, but it's still, your best bet is to use an open file format. All right, and finally, we're getting to reuse. And to do that, you want to select an appropriate repository. There are many different options for places to share your data. First of all, you can include it, for many journals, you can include it with your published article. They also may just want you to host it in another repository and include the link. And there are subject-specific data repositories, aka data repositories, say, just on data for cancer research. Institutional repositories, like Digital Commons at PCOM, are an option. There are general data repositories. The most important thing is that it's discoverable, because you want people to find your data. So how do you decide where to deposit your data? First step, look if you are funded by grants. Look whether your funding body requires or recommends specific repositories. And there is a great link here from the NMLM Data Repository Finder that covers all repositories covered by NIH grants. And it just lets you sort by exactly what you're looking for. You can also look into those discipline or data type specific repositories. And sites like re3data.org or fairsharing.org will let you search a list of reputable repositories and find out, is there something, are there repositories for the specific data that you are sharing? You could also look at general data repositories like Dryad or Mendeley data. And there's a trade-off between going for a general repository or a more specific repository. So you'll probably get more eyes that possibly looking at it in a general repository, but you could also miss the people that are saying, I want cancer data, I'm going directly to this repository that just has cancer data and searches there. And finally, you can deposit your data on the Digital Commons at PCOM. And we are not going to be, so we won't catch the people that are going to data repositories specifically looking for data, but we are free. And if you're required to share your data because of a journal or a grant, then you could just send it to me. We could put it on the Digital Commons. The one thing we cannot do is we can't enforce any sort of guidelines, such as HIPAA compliance. So please make sure PHI is removed on your own. Make sure data is as de-identified as it needs to be. All right, and we're finishing our cycle with anonymizing your data. There are several different open source data scrubbers out there that can handle PHI, can handle other PII, other requirements that you don't want to be in your data, so it's safe to share. REDCap does offer PHI removal, but you need to be able to identify what fields are protected health information. So you do have to understand the HIPAA requirements. Excuse me. And finally, NLM Scrubber is a neat little thing, because these other tools are looking at spreadsheets, and data. NLM Scrubber goes into plain text like clinical notes and can anonymize the data there. All right. Before I go on to data management plans, do we have any questions? All right, let's get on to data management plans. So, data management plans are doing all of that documentation and preparation that we talked about, and having it ready to go before you get started. And data management plans can be required for many grants, even if they're not required. Making a data management plan can help you keep all these steps in mind, have your plan ready, and not be blindsided by, oh, weren't we supposed to think about privacy like several months ago? The components of the data management plan, basically all the things I talked about during the data cycle. And there are several ways to create a data management plan. And all these links are going to be on our research and data LibGuide, which I will link. I'll link in the chat at some point, and also we'll be sending you these slides. So, an NLM toolkit has the current current policy for NIH grants and a lot of free resources on creating a DMP. DMPtool.org is extremely useful. It is a step-by-step tool from the NMLM to create and save DMPs. And it has links to the current policy for each step of it. So for example, for data collection or storage, it will tell you, okay, here's what the requirements say. Here are some links as to how you, with guidelines for this. And here's a screenshot from DMP tool. So you could see data and materials produced. It tells you exactly what you have to have in this section. Over on the right-hand side, it has guidance from, say, the NSF, and DMP tool itself has some has their own help and guidelines over on this tab. So I recommend making your data management plan through DMP tool. Very easy to set up an account. It's free. It'll save your plans. And the step-by-step just makes it a lot easier, and make sure you don't forget anything. So what can the library do for you? We can help you creating a DMP, give you guidance to adhering to FAIR principles, assist you in selecting a repository, and host the data in the digital commons. And down there is a link to our research data management page. And this is just an example of what we have on the page. A lot of the links we talked about and guidance. And I'll continue updating this so it has all the most up-to-date guidelines, and just gives you an idea of what you have to do with your data and where you can look for guidance. Okay, and finally, we're just going to briefly talk about open access because this is open access week. So right now we've talked a lot about our data being open access and freely available. There are also a lot of open access journals to which the library has links to and provides access to. PubMed Central, you've probably seen if you've used PubMed, and a lot of government research is required to be deposited in PubMed Central. And that's why a lot of PubMed is going to be freely available, even without our library subscription. The Directory of Open Access Journals, or DOAJ. If you're interested in open access, I highly recommend just taking a look on the DOAJ and looking at the type of journals that are there. These are vetted journals. The problem with open access journals is that a lot of them are going to be predatory, or just trying to get people to pay fees to publish in them and not actually require it, and not actually giving, say, the peer review or listing in legitimate databases that they claim they do. If you're worried about an open access journal, check if it's in the DOAJ, and that'll help you like limit the journals you're looking at to trusted journals. And finally, we provide some support to publishing open access. So publishing open access usually requires author fees, because if they're not getting money through journal subscriptions, then they have to have money for editing and all of that. They have to get that somehow. Unfortunately, this can end up with very big fees for authors. It can get into the thousands of dollars. Sometimes you get this from publishers who definitely get enough money from subscriptions that they should be able to publish it without author fees, but we won't get into that right now. The important thing is that the PCOM library can cover author fees for these specific publishers: BMC, PLOS, Public Library of Science, and Springer Open. If you are interested in publishing and you want your paper to be available open access, then please go to our Open Access LibGuide. This tells you exactly the journals that we cover and exactly what you have to do to have us cover the costs for each of them. We cannot help you if you select your journal, get published, and then come to us and say, oh, I have to pay $2,000. Can you help me? We cannot. So, like data management, this is something you should be thinking of from the beginning. Read the author requirements for a journal before you submit. Look for a journal either that we can pay your author fees for, or that doesn't require author fees. All right. Do we have any questions? Yes, Thomas.
Yes, quick question. Where can I store large amounts of data that maybe I might get from gene expression and data analysis? I have access to PCOM, my own intranet thing, but it looks like it only has a 5 TB limit. Is there another source that we're supposed to store research data? I'm down here in South Georgia. So I'm trying to figure out where should I be storing large data files?
Talk to ITS. I know at the library we've actually been moving a lot of our archival data, especially videos and such, to AWS, or Amazon Web Services. We do have to pay for that, but it was with the amount of data we have. Yeah, definitely talk to ITS. Know that you have other options, but they'll be able to help you the most.
All right. I know I had some communication like a few months ago, but for South Georgia, but I've never found out exactly where we're supposed to put data.
All right. Any other questions? Yes.
I'm wondering if there's any such thing as proprietary data. So I don't do clinical research, but sometimes I do a lot of data analysis with the school's grades and things. And yes, we de-identify it, but still, I don't know if the school wants that. Obviously we have to follow rules. It's non-funded, so I guess it would be the journal rules at that point.
I would think so. Actually, Jane, do you have any, I don't know exactly what like the school's policies are that. Jane, do you know any of these offhand? All right. Yeah, I would.
We'll just go, we'll cross that bridge when we come to it. But I imagine that
I'm on my way to get a flu shot, but
Oh no, sorry.
that's why I wasn't on camera. So years ago, it was identified on an internal audit that people were using like flash drives and external drives, even though they were like terabytes, for really big files because it was things like confocal microscopy images. For your everyday run-of-the-mill data, it should be in the R drive. If it's really big data sets, then we can talk about it. And if it's a repository because it was NIH or NSF funded, that's a whole different story.
right, and that's for like our storage. But when it comes to putting it in a shareable repository,
Then that's digital commons.
right? But is there
I
anything
think
as proprietary data where it's like
There's no such thing as proprietary if it's for the school because it's work for hire unless you're filing a patent. It's not
Yeah, and-
proprietary if you're doing it on the clock.
Well, I don't mean proprietary for me. I mean like I do a lot of educational data that I get from the provost, associate provost, and I don't know if they want that
Well,
out.
that would be confidential, but not necessarily proprietary.
Okay, then I'm using the wrong term. Confidential. Is there?
There's still the R drive, Lauren, because nobody else can access it, just like you can't access my F drive files.
Well, no, it will be archived. That's not the problem. Is the shareable is the question.
Well, you can put it in M or R. You can make it shareable. You just have to ask ITS to grant permission to other people. So
I
for
think
you and Linda and
for
Michael,
like
for
data
No,
repositories.
Don't want
I'm
to
sorry.
make it shareable. Don't want to make it shareable.
So if it's, you don't want it to be shareable, that's the default. If you want it to be shareable, it could be, I'm just making this up, you, Michael, and Linda.
But what
The
if
default is it's not shareable, it's just you, just like any other F drive
right?
file.
But then you go to publish. That's the question.
So, so I think I don't know the policies offhand, but when you when you do the IRB B for this, this will be when you're figuring out like,
Right,
is this de-identifiable enough?
exactly. Is
that
it
we can
encrypted,
use this.
etc. I gotta run and get my flu shot, but let's talk about this offline.
Yeah, and obviously this won't be implemented till the end of 2025, and we're all in this new territory, so we'll keep learning.
Yeah, all those regulations, though, that I was talking about are for government-funded research.
Well, that's
So if
good.
your data comes from research that's not funded by government grants, you don't have to worry about those particular regulations.
That's good.
All right. Oh, it looks like we have some extra time. Scott, do you want to talk about the training AI?
Yeah, we had this slide in. We decided to take it out because it was off on a tangent a little bit, but this is kind of a new thing now. Chat GPT and these publishers of these large language models here are going to academic publishers now and paying them to have access to their scholarly publishing to train these AI machinery in just in language, and a lot of the publishers are actually selling access to that stuff, but the authors of those articles are not having a say in this. And the author's saying, but wait a minute, this is my copyrighted stuff here. I don't give permission for this. And it's going to turn into another big legal battle too, because some of the public saying, well, but you published with us, so you gave us implicit permission to do this. And the author saying, no, I need to be offered to give you explicit permission to do this. And it's turning into a mess, but it is a thing that's going on. Supposedly you can opt out. So say you're published on a platform and supposedly you can opt out and say, I don't want my data to be read by large language models or anything like that. But some authors have been complaining that they are not being given that option to opt out. They should be, but they're not.
And that also circles back to one of the reasons why open access is so important. So for traditional publishing, as it is now, a lot of the times when you publish, you are signing away your rights to the work. You cannot do what you want with your own work. You're not making money off it. You're not even able to post it on your personal website. And open access, one thing open access does is a lot of open access publications have copyright to the authors. So you have control of your own work. You control whether or not it is sold or used to train AI. And this can be separate from open access. There are templates for negotiating with publishers for keeping the copyright to your own work. But that adds another layer of hassle to what publishing already is. But it's always good to at least be informed about your author rights and who has copyright of your work. What can they do with it? And that's one thing to keep in mind when you're deciding where you want to publish. All right, any other RDM or open access or just general library questions at this point? No, well, I am having open access office hours virtually for the next 2 hours. Let me actually put that link in the chat so you can pop by if you want to come. And all right, I just want the URL.
While you're doing that, I have a quick question. I
Yes.
know you're going to post the recording of this, and you had several good URLs in your
Mhm.
presentation. Would you be putting the slides up as well so that we have the hot link?
Yes. First off, I just linked to our RDM, to our Research Data Management LibGuide, which I'm putting, I've almost finished putting up all the links up on there, including from our cut down, including the slides we had to cut for time. But yes, we'll also be putting the slides up themselves. And I believe we can just, we'll just email them to you. And also we'll put them up on my research profile and Scott's as well, once he has one.
Yep.
Thanks.
All right, thank you all very much for attending. And yes, if you have any questions, please feel free to ask us. Scott is the expert on the regulations, and we can help you out with any of this data management stuff.
Thank you all for coming. We appreciate it.
Thank you.
Take care.